In this video, I want to talk about how to use the compound interest formula and some other finance formulas. So let's first work with the compound interest formula, which is given the form of A, which is the amount after the given time, P, which is the principal or starting amount of your investment, and then you have R, which is rate as a decimal, and which is the number of compounds per year. For dealing with quarterly, that implies n equals 4. For dealing with yearly, that implies n equals 1. Bi-yearly or biannually would imply that n equals 2, and monthly would apply n equals 12. And then the time is always measured in years. So let's work an example. Suppose that $1,000 invested at 8% interest and is compounded annually. How much is the S&E count at the end of 3 years? So we need to use our compound interest formula. Recall is in the form A equals P1 plus R over N to the N times T. So I'm going to highlight a few things. The first thing I'll highlight is my principal, which is P, which is usually given to you. The next thing I'll highlight is my interest rate. I'll highlight that in green. It's 8%, that's my R. Next thing I'll highlight is going to be my N, which is quarterly. And then the last thing I'm going to highlight is T, which is time, which is 3. So now I just plug everything in. First thing I need to do is I need to convert that 8% into a decimal. So that's going to be R equals 8 divided 100, which is just 0.08. So now we're going to say A equals 1,000. Highlight it, and we'll highlight it in yellow. And 1 plus 0.08. Green, so you can see what goes where. All divided by quarterly, remember, implies 4, so 4. So 4 times 3. So let's be consistent with our coloring. So N is 4, and T is 3. From here, I just use a calculator. I'm going to use Geogebra. So let me clear what I had from a previous problem. Delete, and I'll just type everything in. So 1,000, oops, it's one too many zeros. And then, oops, I can hit the key, let me just make it go up beside it. Okay, then I hit the keyboard, then times, make a parentheses, 1 plus 0.08 divide 4, go outside the parentheses, and then hit the exponent button, and then it's just 4 times 3, and the value of my investment is $1,268.24, which is the value that Geogebra gives me. Equals 1268.24, and I'm done. In our next set of problems, we're going to talk about determine the value of an annuity. So A is the value of an annuity is pretty much an investment. So A is the value of the investment. R is your monthly payment, or how much you pay, put into your how much you invest into your annuity. R is your interest rate as a decimal. N is the number of compounds per year. Recall that quarterly implies n equals 4, yearly implies n equals 1, bi-yearly implies n equals 2, and monthly implies n equals 12, and T is time in years. Let's look at an example. At age 30, you deposit $150 at the end of each month into an IRA that pays 4% compounded monthly. At age 65, what will the value of the annuity be? How much interest will you earn? So let's highlight some things. So let's start with the value of R. So let's write down the formula first. So we have A equals R 1 plus R over N to the NT minus 1, all that divided by R over N. Let's make some space. We don't need some. So let's do R is yellow. The big R is yellow. Let's differentiate. The little r we'll do in green, which is 4%. $50. Let's do the number of compounds. N is, we'll do in blue. And it doesn't tell us our year, but I'll highlight two things that will give us a clue. So T, so age 65 to 30. So we have a little bit of math to do on this problem. First, we need to figure out what the value of R is. So that's going to be 0.04, sorry, I'm too far ahead. That's going to be 4 divided by 100, which is just 0.04. To get my T, that's just going to be 65 minus 30, which is going to be 35. Here, I just plug everything in. So it's going to be 150. Grab the highlighters. So again, T is 35. Percent R is green. And then let's start with the yellow. One plus 0.04. And we'll grab the green real quick. The number of compounds is monthly, so it's going to be 12. So 12 times, that's 35 years, minus 1, all that over 0.04 divided by 12. Oh, 12, 35 in pink, and then just the 0.04 in green. From here, what I'll have to do is just plug it in the calculator, and I'll have the value of my annuity in 35 years. So again, I'm going to use Geogebra. You really can't do these types of problems without a calculator. I don't know why you'd even bother trying, because we require a level of math that would just blow your mind. So these calculators are designed as calculator problems. You have to use a calculator. The easiest type is using the Geogebra or a calculator that works similarly like a TI-84. Hit the right arrow. Hit the exponent. 12 times 35. Go down. Make sure you're not out of the exponent, -1. And you might need to add a parentheses. There we go. So that way we're dividing the whole top by the bottom. And then we're going to do 0.04 divide 12. And we get 181,000. Let's write this answer down. 181,759.64. That's a lot of money within 35 years. But that's the point of an annuity for a retirement fund. You want to have money in your accounts when you retire. .6, and I'm done. Okay, we'll do a similar question. This time, the only difference in this and the previous question is we're starting at age 40. So you want to see how much interest. We forgot to answer how much interest he earned. So we need to figure out how much interest we'll earn. So we know that we're putting $150 a month in times 12 times 35. So use the calculator because I don't know what that is off the top of my head. $150 times 12 times 35. And that gives me, I invested $63,000. So that's a nice return. So what I have to do is subtract. And I'll see how much interest I actually made on my investment. 759.64 minus 63,000. And that should give me a pretty nice return on my investment. So all I have to do is do A minus B. Since what's nice about Geogebra, it makes a value for you, so you have to just retype it. So we made $118,759.64 in interest. $1,875,9. And we're done. Okay, next example is the same as the previous example, except we're starting at age 40 to make our investment. So this time it's just going to be 65. -65 minus 40, which equals 25. So all I have to do is use our formula, plug everything in that we had last time. So it's 150, which again, I believe we highlighted in yellow. One plus r over n, which is just 0.04 divided by 12. That's remaining consistent to the 12 times 25 this time. Let's move this out the way. 5 minus 40 equals 20. Minus 1. All that over 0.04 divided 12. Let's grab the highlighter and highlight consistent with our highlighting. That's 0.04. T is 12. And the number of years this time we'll do it in pink, which is 25. So from here, this is what all I have to do is grab my calculator. And if you use Geogebra, it's really easy to switch your numbers out. So all I'm gonna do is go to the where I initially typed it in and change that out to a 25. Everything else remains the same. And that saves a lot of time. So for this investment, I make $121,819.43. 21,819.43. So that's the value in 25 years. Now we want to know how much interest I made on this investment. So to figure that out, what I'm going to do is this. I'm going to first figure out how much I put into my investment. So this time, I didn't have as much time to save because I decided I was late about starting to save money for whatever reason. So we're going to do 12 times 25. And then we're going to subtract it just like the last problem. So this will be, we're going to change the B equation since I already saved that. Change that to a 25. And this time I invested $45,000. Now all I have to do is subtract them. 121,819.43 minus 45,000. Use a calculator again because these are some really large numbers, but it makes sense that we're trying to save some money for when we retire so we don't have to work anymore. So we made $76,819.43. And we'll say that's in interest. Not a bad investment, but the 35-year investment's a little bit better. In this section of the video, we're going to talk about how to find the monthly mortgage payment. So pretty much we had in the last video, we talked about the present value of a loan. And in this video, I've already solved it for you, but we're going to figure out what the monthly payment is if we know what the value of the loan is. In this section of the video, I'm going to talk about how to figure out the monthly mortgage payment for like when you buy a home or like if you're buying a car, but we'll just focus on buying a home in this example. The same formula works when you're buying a car. So first we need to figure out the down payment for the amount of the loan. So we'll do that in a different color. We'll use this dark green for my down payment. So to figure that out, we know let's work with part A. So we know the price of the home is $155,000, and we want to figure out the amount of down payment. So that's just going to be 10 times over 100, which we'll just put that into a calculator because remember, percent we divide by 100. Let's clear some of this old stuff out. So we have 155,000 times 10 divide 100, and we get 15,500. This is my down payment, which is equal to A for the formula. Next thing we want to figure out is we want to figure out our loan amount. So to figure out the loan amount, we need to figure out how much the cost of the house is. So 155,000 minus 15,500. This is going to give me my value of A or the loan amount. So this I'll use the Geogebra calculator. 155,000 minus 15,500. Hit enter, we get 139,500. So this is my value of A, loan amount. Next, we want to figure out how much our monthly mortgage payment is. So we're going to use the formula R equals A R over N all over 1 minus 1 plus R over N to the negative NT. So let's start plugging some things in. We have 139,500. We need to do our interest rate as a decimal. So the interest rate for the mortgage is given to us as 5.5. So just divide that by 100. That would be 0.055. 0.055 divided by we're going to use 12 since we're talking about a loan. They're typically compounded monthly. 1 plus 0.055 divide 12 to the negative 12 times, we're talking about 30 years. Highlight everything appropriately. Okay, now we just use a calculator. So we have, make sure you use parentheses to make sure everything's in the right spot. Otherwise, the division might not work appropriately. make it new parentheses, 0.055, divide 12, go outside the parentheses now, divide 1 minus, make it new parentheses, 1 plus 0.055 divide 12. Hit the exponent button. The negative 12 times 30. I mean, that was $792.07 for a monthly mortgage. Now, part C was asked us how much total interest will be paid. So to figure that out, what we're going to do is we know how much our monthly mortgage is, and we know that there's 30 years being paid, and we're paying this per month, not once a year. Times 12 times 30. So we're going to do 792.07 times 12 times 30. And we end up paying with $285,145.20. Okay, to figure out how much interest we pay, we subtract this from our initial loan amount. So we do 285, 145.20 minus 139,500. $285, 145.20 minus 139,500, and we end up paying $145,645.20. 145, 645.20. And this is how much interest was paid. Okay, and our last example, we're going to figure out how long it's going to take to pay off a credit card bill of $16,000. So the formula we need to use is the present value of a loan formula, which is A equals R1 plus N, R over N to the, make sure I copy it, negative NT, all that over R over N. Yes, I copied it down correctly. So this time we're given how much the credit card bill is and how much we're paying per month, but we don't know how much, how many months it's going to take to pay, how many years or months it's going to take to pay this thing off. So what we're going to do is this, we're going to highlight the A in orange. We'll highlight the monthly payment in yellow. We'll highlight our interest rate in the lime green. And we're going to assume that there's a 12-month compound, 12 compounds per year. Let's assume n equals 12. That's usually how they work these credit card and any type of payments. So let's start plugging some things in. So we have 16,000 equals 800 plus 1 plus, we have to convert that 19.9 into a decimal. That's just 0.9199 divided by 12. So the negative 12t, all that over 0.199 all over 12. So what we're going to do is this. We're going to put this into a calculator, and we're going to look for a point of intersection. So we're going to use Geogebra. So first, we're going to make two equations. See everything out. So we're going to call the first one, type in G. We'll call the first one f of x. F parentheses x equals 16,000. Then the next equation, we're going to type in make a parentheses first, 800 times parentheses 1 plus 0.199 divide 12, go outside the parentheses, hit the exponent button, and we want negative 12. Instead of t, we're going to put x. Negative 12x, all that divided by 0.199 divide 12. Make sure I copied it correctly and didn't miss anything in the equation. You missed a 1 minus. Let's go back and insert that. It's going to be 800 parentheses 1 minus this guy. And let's fix that in the Geogebra calculator. So we'll add a parentheses. Take this out. Times, now add our parentheses. 1 minus. Okay, there we go. Okay, so now we've entered our equation incorrectly. And what we're looking for is this point of intersection here. So in Geogebra, all you have to do is this. You click on the point, and then there's a thing that says point of intersection. So we click this graph and then this graph, It gives me a value of A, and I can see this. We want to show the label, point A. Oops. Shit. Settings. Oops. I don't want that. Okay, we want the value. So our value would be I had it, let me put it back. Intersection. And I'm just gonna put the value on it. So if you go to settings for point A, it takes you to the screen, and then we'll put the name and value on. So in approximately 2.04 years, we'll have it paid off if we make an $800 a month payment. So using the graph that we just used, in 2.04 years, the credit card will be paid. And we're done.